All right, here is an example. I'm going to decide to do it without numbers, just to illustrate. This is most unusual, but it can happen. That illustrates what happens when you need to calculate IXY in a section that has a situation where the IXY locals might not be zero. So let's say that we go through and we calculate the centroid, and the centroid happens to be here. And we have the x-axis and the y-axis. And so we want to calculate IXY. So we're going to say that we have our table, which is the dimensions of our section, if you like, the areas, the shifts, the products of the areas times the shifts, and the local centroidal IXY. Right? Let me double check that this is in view, so I don't go through the same thing. Okay. Now, in this particular case, let me say that I divide this section like this. It's a section, as you can see here, in this shape, and it has this triangular build-up over here. So I'm going to break it like this. I'm going to break it into that triangle, this triangle here. So let's call that one number 1. This rectangle that ends up over here as number 2. This tall thing over here as number 3. And this one over here as number 4. Okay? So when we go to the triangle, my triangle could be A by B, right? So this is just for my notation. I could say A by B, and then I can write triangle or something if I want to just, be clear. So my area here is going to be A times B over 2, right? That's the area. Now, the centroid of that triangle, we know where it is, right? Is at 1/3 of B from this side and 1/3 of A from that side, right? So, for example, we know that from here to here is going to be 1/3 of B, and from here to here is going to be 1/3 of A, right? Now, we now need to calculate, let's say, for example, that the distance from the centroid to the edge of the section, from the centroid to the edge, let's say it was n. Therefore, the shift, in order to move this triangle to the right, this axis to the right to coincide with the xy, will be n minus 1/3 of b, right? And that would be positive because I have to move it to the right, even though it's on the left side, but the shift is to the right. Now, to move this, I have to move it down. So if the distance from here to the top was n2, to the top of that line, then I could see that my shift is n2 plus 1/3 of a, right? Actually, let's call this n1, n1. So this would be n2 plus a over 3, right? And then I can do the multiplications of that times that times that to get this number here. However, these axes are not principal axes of this triangle, right? They're parallel to these, so they have to be, but they're not principal axes of the triangle. These are not principal axes of the triangle. Therefore, since they're not principal axes of the triangle, there is an IXY about those axes over here. What is it? It's a formula. You can find it in a table, in the book, or you can find it in Google, or you can find it anywhere that you find tables for products of inertia of standard shapes. But once you find it, and I don't remember what it is, I think it's 136 of A times B or something like that. But anyway, once you find the value, you put it here, not 0, right? Because the triangle does not have a 0 IXY. So the product of this times this times this goes here, and this is from whatever the formula tells you is the IXY of that triangle about its own centroidal axis. Then we go back to the same thing. Section number 2 would have a certain dimensions, would have a certain area, would have a certain shift, right? Because this is its centroid, so it would be shifted and shifted, no problem. There would be a product, but for that section, the IXY would be 0 about its own centroid because they are principal axes for that piece. When we get to this one has a centroidal axis over here, right? So there would be a dimension, there would be an area. It would have to be shifted, right? Because even though this is like this, the centroid is higher, so this would have to be shifted to the left and upward, right? To the left and upward. So there would be like a negative here and a positive here. And then the product, but there would be nothing about its own centroid. And then finally, this one down here, which would have to be shifted to the left and upward a lot, and would have an area, would have something here, a product, and also again 0 for its own centroidal thing, right? So as you can see, this is an example of, or a situation illustrating what happens when you're calculating the IXY on a cross section, which after you divide it in pieces, there may be some pieces in which their local axes are not principal axes, therefore their local IXYs are not 0, and therefore you must obtain them from some table. I mean, otherwise you'd have to integrate and so on, but that would be impractical. So basically you get that from some table, okay? And then that's the IXY calculation for that. Once you have that, everything follows the same way. You plug into the formula, you would find that the principal axes have certain rotation and so on, okay?